Okay, in this video, we'll talk about mean of Poisson distribution. Okay, mean of Poisson distribution. Okay, yeah. So basic definition for mean or expectation E of x is what? Summation x p of x, right? Now, what is p of x or r p of r? Of course, x p of x here. R successes we are telling now. So let's go with r p of r. What is P of R? Probability of R successes. How do I get it is lambda power R e power minus lambda by R factorial. Okay, so I'll substitute the same thing here. P of R this is. Okay, so summation will be as it is. I'll be having R in the place of P of R. I'll be substituting lambda power R e power minus lambda by R factorial. How can I write R factorial? Can I not write it as lambda power R e power minus lambda by R into R minus 1 factorial? I can write it now. Why? I just want to cancel out R. Okay? Yeah. Now what you do is, of course, this summation, as I have said, as n is tending to infinity, number of trials are increasing. So R also will be very huge. Right? R is starting from 0 to infinity. But then once I write R is starting from 0 to infinity, 0 minus 1 factorial doesn't exist. So I should start this R from 1 to infinity, I should say, because minus 1 factorial is invalid. Okay. Now what you do, what we will do is, let's put what we will do is, lambda e power minus lambda is a constant, right? E power minus lambda is a constant. I have R is equal to minus 1 to infinity lambda power R by R minus 1 factorial. Let's just do one thing. What that is let R minus 1 is equal to T, I will say. Okay, then R would be what? T plus 1. The same thing I will substitute here. E power minus lambda. Now just see, if R is equal to 1, T starts from 0, right? T is equal to 0. Okay. 0 to infinity. Lambda power T plus 1 is what I have by R minus 1. I have taken it to be T factorial. Okay. I think it's legible. Otherwise, I'll write in the next slide. Just a minute. Okay. So okay, what I was saying is e power minus lambda summation. I'm converting everything to t. If r is equal to 1, t would be 0. Okay, infinity to infinity only. T is equal to infinity only. So t is starting from 0 and ending at infinity. Lambda power r value is what? T plus 1. By r minus 1 value is what? T factorial. Right? So to bring it to that old format, I can just write like this now. What that is summation t is equal to 0 to infinity lambda power t into lambda by t factorial. I can write now. Lambda has nothing to do with it. So I'll bring lambda outside. Okay, so it is lambda power t by t factorial. Fine. Is it fine? Now, if I expand this for t is equal to 0, please see here, guys. What happens to this expansion is, the expansion will be something like this. What that is for t is equal to 0, it is 1. 0 factorial is 1. Lambda power 0 is also 1. 1. For t is equal to 2, it is lambda. For t is equal to 3, it is lambda squared by 2 factorial. For t is equal to 3, it is lambda cube by 3 factorial. And so on. This is nothing but the expansion for what? E power x or not? 1 plus x square by 2 factorial, x cube by 3 factorial is the expansion for e power lambda. I mean x e power x. If it is in terms of lambda, it is lambda. So what I will do is, this is equal to lambda into e power minus lambda into this value. This value turns out to be e power lambda. So hence my e power minus lambda into e power plus lambda would be e power 0, which is 1. So, expectation of r or x, whatever, expectation of the random variable x would be what? Lambda only. Or in other words, mean of Poisson distribution is lambda. Variance also is same, guys. Let us see variance as well. Okay. I'll try to finish off. Variance is also similar. Variance of Poisson distribution. How do I find variance? Variance of any x is nothing but e of x squared minus e of x whole squared. E of x I have already calculated. So I'll talk about that later. First check for e of x squared, guys. E of x squared would be what? Summation x square p of x. Okay, but here my x's are, so I'll be rewriting it as summation r squared into p of r would be what? E power minus lambda, lambda power r by r factorial. Okay. Now, there's one small, this thing that I will do for r square. What that is I will rewrite r square as, I'll rewrite, of course, I can cancel out r. There'll be one more r, na? See, I can cancel out here r. R into e power minus lambda, lambda power r by r minus 1 factorial. Fine, huh? Right. Now this r, whatever is remaining, that one I can rewrite it as summation r minus 1 plus 1. Why you are writing, if you ask me, just to maintain the uniformity. Okay. Just to bring something. E power minus lambda has nothing to do with this summation. Of course, the summation ranges from r is equal to 0 to infinite. Here, one r has gone off. So this ranges from 1 to infinite because minus negative or negative number factorials doesn't exist. Okay, lambda power r by r minus 1 factorial. Just see here. What I'll do is, I'll separate the terms. That's it. E power minus lambda, r is equal to 1 to infinite, of course. R minus 1 into lambda power r by r minus 1 factorial. I know what happens. Okay. Yeah. Coming to the next term, what happens here? What happens? What will happen to the next term? Of course, summation is there. I've just missed out this summation. There's a summation here as well. Okay. So there's a summation here. There's a summation here as well. What it would be is lambda power r by r minus 1 factorial. Of course, e power minus lambda is common to both the terms and r is ranging from 1, by the way, from infinity. Here also r is ranging from 1 to infinity, but then once this gets cancelled off, things will again change. Just see here, e power minus lambda is there. There is a summation, okay? Lambda power r is there. Now r minus 1 factorial r minus 1 got cancelled off. So r minus 1 factorial becomes r minus 2 factorial. Hence r should start from 2 to infinite. Okay. And then this is what? Summation r is equal to 1 to infinite lambda power r by r minus 1 factorial. This thing I have already handled in e of x by making a substitution that r minus 1 is equal to t. Here I will say t1. Okay. And similarly, I will say let r minus 1 is equal to t1, r minus 2 is equal to t2. Let's see what happens. E power minus lambda, what I will have will be r minus 2 is equal to t2. So again, t ranges from 0 to infinite because r is 2. Lambda power r would be what? T2 plus 2 by, this is what? T factorial. T2 plus 2 is fine. If it is not okay, we'll change the notation. T2 plus 2. I've written T2 plus 2. Okay. Plus this one, this summation again is this is T2. I'm sorry. This summation is ranging from T1 to infinity. Lambda power T1 plus 1. This is by, what is this? T1 factorial. Now I know what to do, or like how I have done previously. So again, this gets transformed to e power minus lambda. This would give me what? Lambda squared and e power lambda plus this would give me what? Lambda into e power lambda. This is what? E of x squared, guys. This is the value of e of x squared. Now variance is what? E of x squared minus e of x whole squared, na? So I'll put both the terms here. Now if I take inside, what I'll be left with is, if I take this one inside, I'll be left with lambda squared and lambda, and e of x whole squared would also be lambda squared with a negative sign. So both of them get cancelled and I'll get lambda. Hence variance and mean both for Poisson distribution are lambda only. Okay, I'll do some more things in the next video.